An upcoming space company, Astra, is trying its best to surface its strength in space. Though they've been around since 2016, they've yet to see good success in the space race. We can term them upcoming among Blue Origin and Space. The company's mission, to send tiny storm monitoring NASA satellites to orbit, failed after a second stage booster engine shut down early in space. The failure occurred roughly 10 minutes after a successful liftoff of Astra's rocket, meaning they were close to luck but nearly could not kill a bird. Let's have a more interesting discussion about the rocket launch failure. Amanda Dirk Fry, who comments on Astra's livestream, says, "The first part of the flight went as planned, but the engine of the upper stage shut down early, so we didn't get our payloads into orbit." The rocket carried two small satellites made by the Lincoln Laboratory at the Massachusetts Institute of Technology to measure rain and humidity in tropical storms. They were to be the first batch of a 6-satellite constellation managed by NASA, the rest of which Astra also plans to launch in the future. Since Astra was founded, to reach space have been one of the company's most aspiring goals. In 2016, they could get into orbit faster than any other company. However, they lost this ability. As of late 2022, they needed to launch a vehicle or the ability to get into orbit, which isn't a good balance for the space company. Astra's first two rockets, Rocket 1.0 and Rocket 2.0, were suborbital test vehicles without payloads. Their only reported launches were failures. Astra reached the Space Kármán line for the first time on their second Rocket 3 launch. They are third if you don't count a previous rocket destroyed by fire on the launch pad. Still, the upper stage did not go into orbit because the ratio of fuel and oxidizer was wrong. Astra's previous flights on August 28, 2021 with their fourth Rocket 3 vehicle carrying a payload for the United States Space Force failed to reach space noticeably. That is the strangest rocket failure ever. The launch went sideways almost from the moment the engines ignited, with the rocket moving more horizontal than vertical before correcting itself and following an upwards trajectory after 148 seconds. Astra Chief Engineer Benjamin Lyon offered more details about this mishap and steps the company had taken to ensure it does not happen again. While the most recent launch failure was a setback for the company, they are eager to return even more robust. They're enthused about what Rocket 4 has to offer here. The Astros are now releasing more information about what we may expect. Astrospace tweeted a few weeks ago on November 16th that the Rocket 4 Payload User's Guide is now available. This Payload User Guide has a wealth of information about Rocket 4, but let's put it through to you a bit. Rocket 4 is a disposable, vertically launched to stage, lock, / kerosene rocket designed to lower the cost of an orbital missions by optimizing cost effectiveness during rocket launches. Astra emphasizes that the Rocket 4 series results from substantial learning throughout the previous Rocket 3 series design, manufacturing, and even during launch. Astra has concentrated on producing its rockets with tried and true metallurgical structures, leveraging interdisciplinary manufacturing techniques, and issuing laborative processes like carbon composite layers. These techniques enable rapid manufacturing output and lower production costs, which are realized and passed on to customers as you ramp up Rocket 4 production in 2024 to increase launch availability by achieving an average weekly launch cadence for the product life cycle. Looking back at the previous Rocket 3 line launch failures, many of them had issues such as engine troubles, fluctuating separation, and more, all of which Astra is attempting to prevent. With this new rocket centered on Rocket 4, its engine is one of the primary new components. Earlier this year, we got a sneak peek when the company published a short video of the engine firing. We now know a lot more about its unique design capabilities. The first stage of the Rocket 4 is powered by two turbopump-fed LOX engines. Each engine is expected to have a maximum sea-level liftoff thrust of 40,000 pounds. The machine has a combustion chamber cooled by the surrounding area. It works at over 1,000 Asia chamber pressure, which is fed by a turbo pump. Each engine can take a chance to steer and control the vehicle. The thrust vector controls actuators are moved by the fuel drawn from the primary fuel circuit. This fuel is under high pressure. Fuel draw actuation makes the vehicle easier to use because it doesn't need any external source of high pressure or high voltage for systems that require a lot of power. Now that we know more about Rocket 4's new first stage engine, we can take a closer look at its improved structure, upper stage engines, and Astra's launch system 2.0. The engine in the upper stage is fed by a turbopump and has a vacuum thrust of around 6,500 pounds. The engine is a high-performance LOX engine that moves the upper stage and payload into orbit. It can be turned back on before payload deployment and after payload deployment. This lets the upper stage turn around. The engine tested for Astra's use is based on an already tested engine. This is done to lower the orbit of the upper stages. Rocket 4 is made entirely out of metal, and its design is to make rockets as quickly as possible. Astra is trying to use simple and efficient ways to make crafts that lead to lighter structures all over the vehicle. The first stage comprises two cylinder-shaped tanks that are bigger than the Rocket 3 series, but are made in the same way that has been tried and tested. The LOX and fuel tanks are made out of a single piece of aluminum with a dome-shaped top. They were designed and tested in-house. Now, thin aluminum sheets are used to make the domes, and rolled sheets are used to make the cylinders. Helium-C is submerged in the fuel tank for packaging efficiency. There are slosh baffles and anti-vortex devices in the tank. The upper stage is a shorter version of the first stage that uses the same welding methods. Several parts are further optimized for weight on a similar architecture because the stage is more sensitive. It's a commando assembly like the first stage with the helium COPV submerged in the fuel tank. As for performance, Rocket 4 is made to carry a payload of about 500 kilograms to a non-synchronous circular orbit at 500 kilometers in altitude. Astra's plans to run the vehicle with underpowered engines at first to reduce risks related to the performance of the system and the schedule. This means that in 2024, a circular 500-kilometer high sun-synchronous orbit will be able to carry out 350 kilograms of payload. As they learn more from testing on the ground and early flights, they plan to lower the engine D rating, which will make their launch vehicle able to carry more weight. One of the last big changes is how the ship is launched. Astra says that the goal of Launch System 1 was to get into orbit as quickly as possible and show that they could make the rockets in large quantities. But after the problem with their last launch, they listened to their customers, their team, and their stockholders. They decided to speed up the release of a rocket with better performance and add more testing. They think this will make the future launches more reliable. Astra clarifies that Launch System 2 is more than just better hardware. It shows a change in their culture from putting the most emphasis on schedule to putting the most focus on reliability. They are a totally different company than when it launched System 1, and it shows how much money they are putting into making sure the system works. The whole system has been looked at and re-engineered as needed to support their plans to reliably and repeatedly send the payloads of their customers into orbit. Astra is sure they have more resources than they did when Launch System 1 was made. They have set up a new system verification and assurance team, a quality control lab, and a failure analysis lab, amongst other things. Even though Astrospace has state-of-the-art testing tools, it needs to make some big changes to be successful in the industry. Still, between Rocket 4 and Launch System 2.0, the company is trying to create something new and unique, and a lot is changing. Astra seems like a good idea, especially since they want to be like SpaceX and will soon have everything in place. Now that Falcon 9 can take off like a consolidated freight waste truck on its regular route, it's easy to forget that rocketry still needs sacrifices. We must also keep this in mind when SpaceX begins sending starships into space. Even with their experience, we can bet that at least one of them will have to blow up before the company makes corrections for success to come around. Do you think Astra may someday be another SpaceX's main competitor, just like Blue Origin? And talking about Blue Origin, click on the video to know how millions of dollars shamefully sink on its BE-4 failure.